Good morning, everyone. Thanks for coming. I would hope we could get started. We're already a few minutes late, and that's partly my fault. I apologize. Thanks for joining us for the Renewable Energy for Buildings and Homes session. Right now, I feel like energy conferences are kind of in my blood right now because the state of Utah just put on our second annual Governor's Energy Development Summit, and it was a big event, and we were putting together a lot of great panels just like this, and it seems like they've done a great job here today. Let me get this a little bit better. My name is Jeffrey Barrett. I'm again with the Office of Energy Development at the state. I work for the governor, who many of you may not assume is a great advocate for renewable energy, but he is actually getting more and more interested, and as a state, although we don't have a renewable portfolio standard, we do have a great structure of incentives, both on the utility side and on the state side, that can help folks get panels out on their roofs, get large systems built in rural areas and interconnected to the system. So we have a pretty progressive, at least incentive structure, if not a mandate to promote this kind of development activity. But as we see costs drop, which some of these gentlemen may be able to speak to, more and more companies, large-scale solar companies from around the world, are coming to Utah, expressing an interest in working in Utah, and so we could see good things happening in the near term. As I think a lot of folks in this room, including our good partner Sarah Wright here with Utah Clean Energy, could tell you. I mean, companies are taking an interest, they're taking a notice. We've got one of the best solar resources in the country. We're one of just 6 states to be included in the Department of Energy's programmatic environmental impacts statement for solar, the creation of the so-called solar energy zones. 3 zones were created in southwestern Utah, and hopefully that's also turned some eyes to Utah. And we see renewable energy as a great opportunity for rural economic development. We've seen how Milford Wind has really turned a community around, helped folks, help the community build a school, and I believe even a hospital. I mean, it's been a real shot in the arm to that community. So whereas the state is happy to manage tax incentive to give some state revenue back and to help out in that regard, we have not historically touched property taxes because we believe that, at least for the rural areas, is the real positive story about how value can be added to these communities. Even though renewable energy doesn't typically create a ton of jobs at that scale, it still adds a great value to rural communities. The scale at which renewable energy does create a lot of jobs is the scale that we're going to be talking about today, and that's distributed generation. And when you look at the solar industry sort of writ large, the vast majority of the jobs are not in manufacturing, they're in installation. And so the folks who are here today, and I'm just talking about, I've been talking about solar largely, but we're talking about renewable energy, are here from the utility. Eric Anderson is representing Rocky Mountain Power, where he manages, he's the manager of customer generation, and he does great work with them, managing incentive programs, managing interconnection. We have David Eccles from Sound Geothermal, which does geothermal system design for campuses, for homes, and they're doing really progressive work. And Mark Richards from Intermountain Wind and Solar, who's been a great partner to the state, both has brought a lot of expertise and a lot of class to solar in the state of Utah. So we appreciate all of them. And with that, I'm going to pass things off to Eric, who will talk about the utilities programs and other things that you need to know as you consider putting renewable energy on your home or business. Thanks.
Hello, as you said, my name is Eric Anderson. I manage the customer generation group for Rocky Mountain Power. What that means is if you're thinking of putting in a project, no matter what technology, under our net metering rules primarily, you'll be interacting with me or with somebody in my group during that process. We manage both the interconnection process, which is sort of the technical process of interconnecting your system to the grid to make sure that our grid doesn't hurt your system or your system doesn't hurt the grid. And we also manage the incentive programs. And as many of you know, we just released a large expansion of the Utah Solar Incentive Program. There has been a really small program going on for 5 years, since 2007, which is really a test model for us. But through a regulatory process that went on for almost 2 years that many of the people up here participated in, a large expansion was instituted and went into effect the first round, the 2013 reservation period. We just completed that reservation period. We've selected the participants for this year, and we're starting to work with those people to get their systems installed. The program is a 5-year program, so we'll continue to be going forward and working with that. But we got some of the kinks out this first year, and now we'll have a much more expanded program. So what I want to really talk about, this program is to talk about how to put systems on your homes and businesses. And so the primary method that people do this with is through our net metering rules, and these are designed to help people who want to offset their on-site load. Net metering isn't designed for people who are interested in sort of becoming an energy entrepreneur or selling energy back to the grid and having Rocky Mountain Power purchase the energy, but there are options for people. If you are a large landowner, you can interconnect and use different sets of rules. But there is a regulatory construct that's used if you're net metering and you want to just put a small system on your house, or a relatively large system up to 2 megawatts on your business. And that can offset quite a bit of a load. So in Utah, the rules regarding net metering are actually some of the best in the country, or if we've been rated an A by the International, or the Renewable Energy Council, because they allow multiple technologies. Everybody seems to focus on solar when you're talking about this, but it's really open to basically any sort of renewable technology out there. There are caps for a residential customer. It can only be a 25 kW system. That's going to offset most houses. You'd have to be a pretty big McMansion to not need more than a 25 kW system. Commercial customers are limited to 2 megawatts, and that's a pretty big system also. That's a lot of solar panels at that point. These rules are put together through the regulatory process, and we institute the rules that are given to us by the Utah Public Service Commission. So there's some basic first steps that we like to have people keep in mind, because when there's a problem in a net metering application, it's normally that one of these steps weren't followed. You know, getting an early involvement of a contractor and just letting us know what you're planning on doing through the process is really good. We have a group that's specially designed or designated to work on this. If you can just get us the designs, get us the thoughts that you're going through, we can help you work through the process, give you any, if we notice any sort of problems up front, like the transformer's too small for the system you want to be in, we can give that information to you up front, make sure that your design works with our system, and short circuit a lot of problems. The only time we really have problems with these situations, even the large ones, the 2 megawatt systems, when you don't contact us early in your project development cycle and let us know what you're planning to do, and let us know if there is some issues, how to factor that in and how to handle those issues. So getting your information to us as early as possible is great. And then you have, after we approve a program, you have an unlimited time in essence. I think it's a year by rule, but we don't hold people to that. You know, you approve your project, you build it at your whim, but then you know there's not going to be any problems. And then you get interconnected, you get the system, and you get it reviewed by the local building inspectors. We don't do much inspection ourselves from the utility perspective. So you get it reviewed by the local building inspectors, and then you get the net meter installed, and you start producing your own energy. Like I said, we recently released a large program. In essence, we're going to be incentivizing the installation of about 60 megawatts of solar over the next 5 years. It's going to end up costing about $55 million between incentives and administrative costs. The goal of the program is to pay approximately 20 to 25% of the solar systems. That's what the target was when we were working on the incentive levels. That on top of, at least until 2016, a 30% payback from the federal government can really buy down quite a bit of the cost of the solar program and really make the return on investment a pretty quick payback for these systems. The incentives for 2014 are going to range from $1.20 to 75 cents per watt, per installed watt. There's a few, restrictions on the program. We're only going to incentivize up to 4 kW for a residential system, up to 25 kW for a small commercial system, or all the way up to a megawatt for a large system. Each of these different systems has different caps and different incentive levels, and there's a slide later on that talks about that. As was evidenced in our 2013 program, there's a lot more interest than incentive capacity for this program. We had over 1,380 people apply to participate in the program, and about 350 of them were selected to participate. We selected that. How the process works is every year we open up a 2-week window at the middle of January, and we collect everybody who is interested in participating that year. We then send out to a third party, and they just do a lottery, a straight lottery, and determine who's going to participate. They give us a list back, and we start contacting the people who were selected, and they get offered capacity in the program. We're in the process of working with those customers now that we're selected to ensure that they're actually going to develop their project. If anybody drops out after the lottery, we take that available capacity and we just sort of pass it out to the next person on the list. There's a few rules. Probably the most important rule to know is to participate in the lottery is you have to be a new system. So if you put in a system in 2013, you wouldn't be able to participate in the 2014 program. You have to be accepted into the program. We're not sort of retroactively making payments to people who've previously installed systems. Many of the other rules, we generally encourage people to work with a solar contractor, get a solar contractor involved early. You don't need to get much information. You just talk to them early, and they can provide you what you need to participate in this program. There's some of the numbers from our 2013 results from just what happened. We had about 6.5 megawatts of capacity available this year, and we had 28 megawatts worth of projects trying to participate. As you can see in the residential program, we had almost 1,000 people try to participate in residential, and it's a smaller system program segment, so only about 172 people were selected to participate there. But we had a lot of large companies trying to participate. There's been a lot of interest from the commercial sector. That's not all nonprofit. There's many large commercial customers are trying to participate and get into this sector. And we're going to have about 20 projects over 25 kW that are going to be installed this year. As the program develops, it's designed to expand the amount of capacity that's available, but slightly shrink the incentive every year going forward. So if you think you want to do it, try to participate right away up front and try to get that highest incentive level. Another program that we'd like to let people know about, where the utility is incentivizing the installation of renewable energy projects, is with our Blue Sky program. Related to the purchase of energy, many of you know that you can buy green energy from us through our Blue Sky program. And as part of that, some of the money is reserved to actually incentivize the development of local renewable energy projects. Some of it goes, or most of it goes, to buy RECs and green energy on a larger scale from wind farms and the like, but there's a certain portion of that is reserved for incentivizing sort of community-based projects within the service territory. Previous recipients have been schools, colleges, community centers, nonprofits, those sorts of things who want to get into this game and don't have some of the resources. You know, recently the North Davis Prep School put a 10 kW system, and the First Unitarian Church put a system in. So those are the type of projects that that get involved in a program. Selection, typically, it's for any method or any renewable technology. But it's done through a grant process. You fill out a grant, you submit it to the company, and it's sort of evaluated on numerous different matrices for who gets selected to participate. A lot of it is based on sort of community and educational benefits, so it's really beneficial for nonprofits or community organizations who are looking to get into the renewable energy sector. And the reason we really bring this up is because we're starting to collect applications here in March. So if you think that you might have a project that might work for this, it's a good time to start looking at some of the grant or looking at what it takes to participate and starting to gather the data to fill out the grant request. So, I mean, I'm happy to answer questions later. I wanted to keep this brief so we can get all of us talking and get to the questions at the end. So thank you.
Thanks, Eric. That's really helpful. I sat on the review panel for the Blue Sky grant program this year, and most of the projects that applied were awarded, if I remember correctly. And in almost every case, we gave them 100% of the project cost. So it's quite a program. In some cases, we said that's a little bit much in terms of system size for your facility. But for the most part, you applied for a project. You're a school. You're a and we gave them a full award, so it's pretty amazing. Next, I'd like to hand things over to Mark Richards, who's the head of business development for Intermountain Wind and Solar. Intermountain Wind and Solar recently partnered with my office on a Recovery Act, a stimulus program that put solar panels on the roofs of schools, 82 schools in 27 out of Utah's 29 school districts. Small systems, 20 panels or so, something like that. But one of the primary values that we were excited about was all the school teachers, the science teachers were educated in solar technology. They had software for tracking it, and so they're actually incorporating it into their curriculum. So it's really exciting. Anyway, thanks, Mark, for coming.
Good morning. My name is Mark Richards, Intermountain Wind and Solar. Good looking group. Thanks for your attendance. It says a lot about what we're attempting to do here. So hopefully we can convey some good information to you. Thank you, Eric. Good information. Happy to help you with dissecting that program even more if you need some more help with that. They've asked me to speak specifically to solar technologies, but first of all I wanted to thank Lori for her earlier discussion. And we got to participate in installation of that system. So you got to see some of our good handiwork up there. I also wanted to thank Utah Clean Energy. So some years back I had a dream to be involved in the renewable energy industry. And I wouldn't be standing here today if it weren't for some of the programs that Eric talked about and if it weren't some of the work that Utah Clean Energy has done. So I wanted to thank you while I was up here. We get quite focused at times on the R&D of our industry, and I'd like to bring you down to reality of what we're actually putting on roofs today. We've had the advancements in technologies in our industry over the past decade have been significant. And so I keep having people call me and talk to me about what's the next latest thing, and what I'd like to introduce you to is, although specifically PV solar may look the same as it did 10 years ago and even 20, that the advancement in that similar looking solar panel has been significant. And so we've arrived. We have a product that is priced well, that has a long warranty, and we're here today to be able to help you with that. I think we get caught all too often in this miracle magic R&D that someday it will be whatever, and today I'd like to help you focus on the amazing products that are being mass produced as we speak. 4 years ago when I started in the industry, the state deemed a project under $10 a watt installation cost as viable And they still do. And today we're probably below $4. And on large commercial projects, you're seeing much better numbers than that. So our goal, and any country or state or nation's goal, is to have grid parity. And that's when the solar, putting in the solar, the renewable energy on your roof would equal what you would pay from the power company. My goal here today is not to talk you out of the great benefit that we get from the power company. We have this tremendous resource from the power company to be able to interact with them. And it's no small step that net metering exists. It is a privilege, not, it's a privilege that we have that ability to tie in with the power company. So on your home, you do not need to have a battery backup system. You can just interact with the power company. And they've gone above and beyond and out of their way to make that happen. And so we're grateful for that ability. So much of the work that I do wouldn't be done without that ability to be able to net meter. And this advancement of SB 12 to the term we're starting to hear in the industry, I guess we've heard it for a while now, is called virtual metering, I think is more specific to SB 12. Not necessarily virtual net metering, but virtual metering. So we're excited about that possibility. So cost reductions have been tremendous in our industry. I wouldn't even thought it possible that I sit here before you today and talk about the costs to install on your home. I didn't think that would be possible. When I talk to you about the innovations that have been done, we're talking about U.S.-made manufacturer product. We don't have to go overseas any longer for that product. In our industry, we do both, so you have that option today. We've had significant advancements in inverters and our ability to invert that solar, whether in a string fashion or with a microinverter. We can now purchase inverters that interact with batteries, and that's been significant in our industry. AC coupled systems. So we can bring power into the home from the power company, we can bring power into your home from the solar, and we can bring power into your home from the batteries. So we're there. No longer do we need to wait. The cost has come down enough. And last but not least, I would just talk about what's my passion is about diversifying our energy portfolio and how significant that is. I think at one time we saw renewable energy as the opposite of what we were producing in this state. And I think what the Energy Office, Jeffrey Barrett is talking about, and Utah Clean Energy is the ability to diversify. It makes sense that we find a way to power all the things that we need in more than one way. That's it for me.
Thanks, Mark. I want to sort of follow up with a couple of things regarding sort of both of the last two presentations we've heard. Mark, for $20,000, what size system can a homeowner put on their house, roughly?
Well, there's lots of variables. 20,000 would probably get you a 6 kilowatt system, but traditionally homeowners today are probably spending between $12,000 and $16,000 on their home. The amazing thing again with net metering is that you can take your budget and offset whatever portion you need to offset. We get stuck in this mindset that I'm only going to do it if I can offset all the power I use. And what I'd like to encourage you to do is define the budget, offset what you can today, add to that system later. You can offset a fourth, a half, whatever portion you choose. The power company does not analyze the amount of power you produce in your home. They tend to view it more as a reduction in your demand or your need. So find a way, find a budget, and then be able to put that on your roof from one solar panel to, I think we've done some residents that have had a significant amount. I have a number of residents right now who are attempting to do 100 kilowatts on their residence, but Rocky Mountain's going to have to approve that since the cap is 25.
But anyhow, my point, I mean, Eric was speaking to the combination of the layering of incentives, and where we are now is for a $20,000 system, The federal government will give you 30% back in taxes. Rocky Mountain Power will give you 20 or 25%. So say that gets us to 50, and then the state will give you 25% or $2,000, whichever's higher. Well, or whichever's lower. $2,000 is lower. So we're talking 50% of system cost minus $2,000, and that's the effective cost of your system at the end of the day. So that's a significant incentive structure, and it's one that with falling photovoltaic prices and falling prices for other technologies we could really see a lot more deployment, and it's pretty exciting. And with that, I'd like to introduce David Eccles with Sound Geothermal. He is the designer of geothermal systems and project manager. And they do, like I said before, some really innovative work on campus design and really bringing geothermal resources to bear on large systems rather than just on specific homes, although they do homes as well. David?
Thanks. Thank you, Jeffrey. I'd like to thank the sponsors and Weber as our host. It's really exciting to see so many people here. I think that's indicative of positive things for our state in the years to come. We have a very brief time today, so this is going to be very much the Cliff Notes version of geothermal heat pump technology. If anybody wants more information, feel free to hunt me down later. As Jeffrey mentioned, the company I work for is Sound Geothermal. We are based in Sandy and design geothermal heat pump systems. We've worked all over the United States. Primarily the focus is Las Vegas to Jackson Hole, and everything from 1,000 square foot affordable housing. We've worked with Salt Lake County, Park City, HUD, up to entire college campuses, institutions similar to Weber. So geothermal is a little bit different from some of the other technologies being discussed in that it is a thermal technology, not an electrical generation technology. The type of geothermal that we're talking about today, it's ground source heat pumps, geothermal heat pumps, geoexchange, those all mean the same thing, and they are different from high temperature geothermal used to generate electricity, which is a completely different technology. We move energy that already exists underground using a heat pump and an earth coupling, which I'll explain a little bit more in a minute. And when we move heat from the building to the ground, that's cooling. And when we move heat from the ground to the building, that's heating. And a system properly designed functions as a thermal battery over time. So the air conditioning that you do in the summer is actually providing some of the heat that you will use the next winter. So as I mentioned, it's a thermal technology, primarily heating and cooling, can also be used for industrial process. Heat can be used for data centers. But they do all of these things at drastically reduced operating costs, maintenance costs, higher energy efficiency, longer equipment life cycle because everything is either indoors or buried underground, not subject to weathering, et cetera, and a number of other benefits. I'm going to focus on energy efficiency since that's why we're all here today. Compared to conventional heating equipment, which around here it's mostly natural gas or propane if you're up in the rural areas, combustion is always going to be less than 100% efficient. Geothermal heat pumps, on the other hand, because we're moving energy, we're using some electrical input energy to run fans, compressors, circulating pumps, et cetera, to move energy from the ground to the building. And so our efficiencies are greater than 1. They're rated in COP. A COP of 3.0 is 300% efficient, for example. In cooling, you can see there's also a significant benefit there, up to roughly twice as efficient as conventional cooling equipment. To kind of wrap our brains around that, if you're using electric resistance heat, right up here, this one, if you think like a baseboard heater, okay? If you buy 1 BTU of energy or 1 kilowatt of energy and use it in electric resistance, you get the heat output of that 1 kilowatt or 1 BTU 100% efficient at the source, or sorry, at the point of use in the building. If you're using a geothermal heat pump, that same kilowatt that you purchase has a multiplier effect and can move the heat equivalent of 4 kilowatts, or if you're thinking in BTUs, 1 BTU of energy input gets you 4 BTUs of energy output at a COP of 4.0. And that's a common COP for high efficiency geothermal systems. This is why geothermal heat pump technology is a renewable energy. All of that green portion of that pie chart is renewable energy from the ground. Now, conventional alternatives, you're looking at, say, an existing non-condensing furnace or boiler or a condensing furnace or boiler. You have to buy all of the energy that you need for the building, and then in addition to that, you have to buy extra energy that you lose in the combustion process. Okay, and so this I think is a helpful way to kind of conceptualize energy usage with a geothermal system versus with a conventional system. To put some dollars behind that, a common energy management calculation is to look at energy in terms of dollars per million BTU. Million BTU is an arbitrary number. It's just for an apples to apples comparison of if I need a million BTUs of useful heat delivered to a process or a building, what's the actual cost of that given existing utility rate structures and equipment efficiencies. And you can see here, this is based on kind of normalized utility information for Salt Lake. And you can see that geothermal, this is a COP at 3.6, by the way, represents the low end of the geothermal spectrum. That's the Energy Star minimum for geothermal heat pump systems. This is a 4.5 is more typical for the higher efficiency systems available. And you can see that even though gas is cheap in Utah, we still beat it by a fair margin. On the cooling side, and this is million BTU rejected, you can see there's also a significant advantage. Again, the 17.1 EER, that's the efficiency rating for the minimum Energy Star heat pump, and more typical for a high efficiency application is approaching this 28 EER. So that's why people are doing this. I mean, there's real money to be saved, and both homeowners and businesses are taking notice. From the environmental standpoint, geothermal heat pump systems, again, because they're utilizing essentially free renewable energy from underground, have the lowest CO2 emissions of any of the heating and cooling technologies currently available. And if you couple a geothermal system with a renewable source of electricity, like solar or wind, then there are zero CO2 emissions associated with the entire heating and cooling process for a facility. And that's a really big deal. We love all of the renewable technologies because oftentimes the results are greater when you combine them than they would ever be if you use just one all by itself. Briefly, I'll get into a little bit about how the systems work and one of the more typical types of systems. Any geothermal system has three main components. There's the ground connection or the earth loop, and this is the heat source and the heat sink. There's the energy mover, and this is the water source heat pump. Could either be air distribution or water distribution, and then the interior distribution system, which is just your ductwork or your radiant piping, or an industrial process, say for example. This third component is identical to what it would be in virtually any other system, so I'm not going to talk about that at all. The heat pump, I don't have a lot of time to get into the details, but suffice to say that the compressor technology used is essentially the same as you have in your refrigerator at home or any conventional air conditioner. The key difference is that instead of being coupled to outside air where it just rejects that heat regardless of whatever the temperature is, we're coupling it to the ground, which is a much more efficient heat source and heat sink because of the relatively constant ground temperature over the months of the year. And as you can see here, the ground temperature varies across the United States. It's dependent primarily on latitude and elevation because it's essentially the ground is a thermal buffer, and it's impacted by the mean annual air temperature. We've tested values in the Salt Lake area or Ogden to Provo, say, anywhere from about 50 to 60 degrees Fahrenheit. About 53, 55 is typical. And you can design a geothermal system for any of these locations. We've done projects in Alaska and people have done projects in the tropics, but the project has to be, or the design has to be tailored specifically to those local temperature and geologic characteristics, and that's a large part of our job. There are a lot of ways to couple a system to the ground, including open loop systems where you're using a water well pump and re-inject strategy. Closed loop systems submerged in surface water, lakes, ponds, rivers, etc. Horizontal systems, closed loop piping circuits buried underground, 5, 6, 7 feet below the surface. But by far the most common type of system in our area is a vertical ground heat exchanger, partly because for small urban lots, that's the most practical way to fit the system into the site constraints. And it's also the most common commercial system as well. It's very common. Davis School District, Jordan School District, Duchesne District, St. Pete District, a lot of the school districts in Utah have adopted that as their technology of choice for new construction schools. So I'll talk a little bit about vertical closed loop systems. Typically, the depth of the boreholes is going to be anywhere from 100 to 500 feet deep. Commercial systems tend to be deeper just because we're trying to fit more capacity into a smaller space. Residential systems are often in the 200 to 250 foot per bore range. And you'll have an array of boreholes, multiple boreholes, depending on the size of the load. Of course, one of the best things that you can do to reduce the size and the cost of a system is, and this is similar to to a solar array. If you use efficient lighting and appliances, then your solar array can be smaller and have a bigger impact on your energy. The geothermal is the same way. Anything that you can do to reduce the heat loss or heat gain of the building, more efficient insulation, better windows, etc., reduces the size of the system, reduces the footage of boreholes that you need to drill, and that's the most expensive part. I put a system in my own house last year, and so I've got some pictures of that. This is a typical drill rig that does that kind of work. It's a mud rotary rig similar to what you would use for drilling a water well. And this is all pretty typical. The only thing that's different there is that because my house was a retrofit and I wanted to keep my neighbors happy, I have a little containment for the mud there. But for new construction, that wouldn't be there. You can see over here, actually the next slide shows it better. This is the high-density polyethylene pipe that gets inserted in the boreholes. And then the circuit is headed together using heat fusion. So everything that's buried underground is essentially one continuous piece of plastic pipe, extremely durable, no mechanical fittings, nothing to rust or corrode or leak. That's what it looks like underground. And this is a big part of the challenge for our industry because when a system is completed, it's invisible. All of the equipment is in the mechanical room. All of the really important part of the system is buried underground, potentially up to hundreds of feet deep, and no one ever sees it. People go in geothermal buildings all the time and have no idea that that's a green building. It doesn't advertise itself as well as a solar panel or a windmill. This grout, by the way, is critical for the both sealing off the borehole and also for providing good thermal contact with the earth, and that's a bentonite-based grout, usually augmented with sand for better thermal conductivity. But this is, again, it looks basically like a furnace. This is the heat pump here, ductwork connected to it, piping coming in from the ground loop. This is a typical residential install, not my house, but another one. Pump module here, and so water is circulated through the ground loop, either picks up heat or dissipates heat, and then flows through a heat exchanger in the heat pump and back out for another pass. And that's by circulating that water through that buried heat exchanger, that's the heat transfer mechanism. You can see this one here is also actually connected to a domestic water system for heating water. This is a screenshot from the monitoring system that I have on my house. It's participating in a Department of Energy study looking at the efficiency of geothermal heat pump systems nationwide. And I won't get into a lot of detail here, but this was taken January 26th, and we had one of the coldest Januaries in the last 30 years in Salt Lake. And my COP is 4.5. That's 450% efficient. So for every kilowatt hour that I bought to put into the system, I got 4.5 kilowatt hours worth of heat back. And this is the productivity of the system since install. Cooling values are shown as negative and heating is shown as positive because it does both. And I took this last night actually, and as of last night it was more than 47 million BTUs of thermal energy generated. So that concept that's used, the same concept that's used for small residential projects, can be applied to large facilities like schools. This is a school in Las Vegas, Nevada. And you can see here, this was taken before the system was buried. Each of these circuits right here is 5 boreholes manifolded together. So you can see quite a number of boreholes here for this school, and can be scaled up even further. This is one of our largest projects, Mesa State College in Grand Junction, Colorado. It's similar in size and scope to to Weber's campus here, and we were asked to design a system, a geothermal system for a single building, and then shortly thereafter to design one for the building across the street. And we said, well, why not link them together? Because one is a dormitory and one is a classroom building, and they have different occupancy schedules, different peak heating and cooling demands, and we can actually share thermal energy back and forth between buildings before we even touch the ground. And at this point, that system has grown incrementally. We've participated in the campus master planning project as they've renovated and constructed new buildings. And so now we have a central geothermal distribution pipeline that runs all the way up this central core of campus here. And as of today, it's almost 1 million square feet of conditioned space integrated under a district energy system. Geothermal bore fields have been drilled under different green spaces and parking lots throughout the campus and tied in incrementally as more buildings have been tied in. We've planned stub outs in various locations for future construction so that as they continue to grow, they can tie into the system. And we're currently in the design phase for over 300,000 square feet of additional space this year that's going to be tied in, including the gymnasium and aquatic center, and then some new dormitories that are actually off the map to the left up there on the north side of campus. And this is a really important thing, and it's similar to what happens with the electrical grid, where the biggest bang for your buck actually with renewables comes from realizing that that loads are not necessarily simultaneous. If you look at the sum of peak loads, all of a sudden covering everything with renewable energy is an extremely daunting task. But if you look at the net coincident peak loads, if you look at, say, for example, a dormitory and an office building have different peak needs, both thermally and for electricity, then all of a sudden the target that we have to hit becomes a lot more reasonable and a lot more attainable. And that's it.
So we're doing okay on time. We have nearly 15 minutes, well, more like 10, I suppose, to be fair, for questions for any of us. So hands, and we can pass the microphones out if need be. Just one second, let me start walking. Does anyone have any questions? Oh.
For the cost of geothermal, did that include installation? Where you talked about the dollars per million BTU or whatever it was?
No, that's the dollars per million BTU is the energy cost, and it takes into account the rate structure from the local utilities and then the efficiency of the equipment. So a geothermal heat pump at, say, 400% efficient versus a furnace or a boiler at anywhere from 80 to 90% efficient. So that's energy cost straight.
Okay, so your installation costs are in no way embedded in that?
No, that strictly has to do with energy purchases and production. Yeah.
Other questions? Just one second. Let me make my way back.
This is just a question for Mark. And Mark, I have a question for you, and it's around, you had mentioned, when we reach grid parity. And I was wondering if you have been seeing residential systems go in with a payback of about 13 years, but they're guaranteed for 25 years. Does that not mean that we've reached grid parity already?
Great comment, and I think you can look at that a variety of ways. In some of these systems now, especially with Eric's help here, we're seeing the year payback period, half of that. So that's a great way to look at it, and we're there. There's a variety of ways to look at it, but I'm going to go with what you just said and support that. Yes, we're there.
Well, my only comment would be in terms of the we're there-ness of solar, for example. Over the last 10 years before the Recovery Act hit, we saw a pretty steady growth of the renewable energy tax credits that we authorize as a state. the program was growing at, I don't know, 20, I haven't looked at these lately, but this will give you the idea. 15%, 20% a year, pretty steady since the early 90s. The Recovery Act hit, and our office had stimulus funds to run a program of similar scope in terms of the degree to which we paid for your panels, similar scope to Rocky Mountain Power's. And we ran that program for 2 years. And in those 2 years, if you had carried that 15, 20% growth out into those 2 years, you would have anticipated X number of panels, right? And we had double that number of panels incented through the tax credit those years, double than we would have anticipated given the growth in the past. So that was a huge jump in 10 and 11, 12, whatever it was. And now Rocky Mountain Power has an incentive that is comparable to that, that's going to go for 5 years, and we're going to see that growth continue. So it's pretty amazing. It's a pretty amazing time in terms of distributed deployment. Other questions?
Are you seeing people install solar if they are not in the lottery, they don't get the incentives? Excuse me.
Yeah, yes, we still, I mean, our numbers have doubled in 2010, 2011, we doubled, but they stayed through 2012 when we still had a small program. The state program was wearing down, was running out of money, and not as many projects were through that, and our numbers stayed consistently grew. I think it was another 50% in 2012 from the 2011 numbers. So, I mean, we're seeing about 2,000 systems go in a year, and 350 of them are going to get money from us. So there's still systems going in.
And we, as of a week and a half ago, had authorized 1,000 tax credits for solar panels this year. And that's before, and of course, if you imagine you're filing for a tax credit, you're going to do it in the last month before before your taxes come in. So we're going to see, 1,400 systems this year at least that apply for tax credits. Other questions?
I can just yell.
Okay.
So the payback is about 7 years if you get the tax credits, and what is it if you just did it on your own?
Well, there's a federal and state tax credit. So there's a variety of reasons to do solar, and we can certainly help you analyze that. We have some sophisticated software that could help us analyze that return. It's one of the few investments I know that once it's paid itself off, it begins to pay you back continually after that. So all I know is that I wished I would have installed mine sooner than later. But we are seeing some amazing, when I started looking at this industry 10 years ago, our payback period was over 30 years. So we've extended the warranty on the product. There's not a lot of working parts, so it just tends to do its job with little to no maintenance. So we're just at an amazing time, but it is an investment on your part, and you will realize the return in that investment. But I think it speaks more loudly to maybe your desire to reduce your need for power. It would speak loudly if you had an environmental slant to your reasoning to want to do that.
What would you guess it would be if you didn't have the incentives? We just said that it would be about 7 years if you did have the incentives. What would it be if you didn't? Payback.
Currently, you can capture a state and a federal tax credit. If we incorporate that in, and if we also wrapped in an average increase of cost of power along with that analysis, we're probably in that 12, 13, 14, 11 to 14 year area.
How about the end-of-life disposal? Are those costs included?
We had a project recently. The government did one of the largest projects in the nation here in Utah. It was a $15 million project back in 1980. And today that project would cost probably about $1 million to do. But those panels were 30 years old, and we pulled those panels off that project. So many of them were still performing, we put them in a container and shipped them to Uganda. So we haven't come to that point of having to retire those panels yet.
At about 18 or 20 years, the panels just, they start to degrade by my understanding, but they're still producing energy. Instead of, they're producing at 80% or 75% of what they were at year 8. So there's still value there. You're not going to rip them off your roof at year 20 or year 25. If I'm the homeowner, I'm going to let them stay on as long as they're as long as they're giving me any value, because it's already paid back.
There's no hazardous waste involved in that. So silicon, which is sand, we've got glass, and we've got aluminum, and some wiring, some wiring.
Other questions? Yeah.
I was talking to a guy the other day, and he had some questions about the carbon footprint of producing solar panels. They seemed to think it was quite huge. Could you comment on that?
You can do your own personal research on that and look that up. What we're showing is if a client will use the solar panel for about 3 years, that'll pay back the carbon footprint of what it cost, the carbon footprint of the manufacturing of that solar panel. So we're showing about a 3-year, all of my analysis has shown about a 3-year equalization of what it, equalization of that.
We're about at noon. We can do 1 or 2 more questions, but just 1 second.
What would you estimate the initial investment to be if you were to put geothermal and solar panels onto the average home?
What's the average home?
What county are we talking?
Yeah, exactly. I mean, okay, so I, and I say that a little facetiously, but it's an important distinction. That is this one off? Oh, it's an important distinction because I mean we work on houses that range from 1,000 square feet to 30,000 square feet. I mean, but I think that someone asked earlier what do you get for 20 grand, right, in the solar world? And 20 grand for a geothermal system, if we're talking about the part outside the building, assuming that you're going to have to put in some form of heating and air conditioning system inside the building anyway, and with the current incentives, the cost for the part inside the building is basically equivalent to what you would put in for a high efficiency conventional system anyway. The extra cost is what's buried in the yard. And so for 20 grand, I mean, you should be able to do a 2,000 to 3,000 square foot house, even in Salt Lake, with vertical drilling. If you live in a rural area where you have a horse pasture or something where you can do horizontal installation, which I didn't really talk about today, that cost could be easily, a third less. And so the other factor that we're starting to see and impact the geothermal installation cost, I know solar has come down a lot in recent years, and I think that geothermal is poised to do that as well. In particular, one of the local home builders has embraced the technology in the last couple of years, and there are, just as with all things, there are economies of scale to doing a lot of drilling at one time under one contract in a single subdivision. And so your price per foot installed is reduced if a builder goes in and tackles an entire subdivision all at once versus doing a single home here and a single home there. And for the same reason with geothermal, usually the payback period is actually shorter for larger commercial projects than it is for residential projects, although residentially I've seen it range anywhere from 2 years to 15 years.
I think that about does it. I just want to again stress how, given where we are with the incentives right now, it's kind of a golden. It's one of our first sort of golden eras of getting renewables on your house, getting them on your business, and any of us are happy to be resources for you as you consider that. You guys, if anyone wants to talk with me afterwards, answer any more questions, I've got some cards, and I'm happy to stick around and chat with anyone, as I'm sure our panel will be as well. Thanks so much for coming.